Hello. I don't think anyone has joined yet. Let me see the participants list. Yes, Saransh is joining in. Let me share my screen in the meanwhile. Hi, Saransh.
Hi, Bhawnik. How are you?
I'm doing good. How about you?
Good. Doing good.
Let's wait for 2 minutes, then we'll start.
Mhm.
Don't have much to do today. Just a few simple things before we start with other areas. So,
Your voice is quite low.
yeah, I was actually speaking lower. Is it clearer now?
Yeah, now it's better.
Okay.
Good.
Okay. Let's just wait. I think let's give it a start. Others can join in. Okay, let me just add Rohi as well. Okay, so
Sure.
let me add Mugdha as well. I think Rohi has joined in. Very good. Mugdha is joining in as well. So hi Rohi. Hi Mugdha. Let's give it a start then. I think the rest of us can join in. So what we have to do today, there are some very specific points that we are going to cover along with a few examples which I'm going to show you, and then I'll go through some of the documentations and the links I'll share as part of the email that I'm going to send at the end, right? So we are going to look, as we have already looked into functions and how to define functions earlier. So we are now going to look into another way, you can say, of efficiently creating a Python function. So this way is known as lambda function, and this concept, as I may have mentioned earlier, has come from the functional programming world. So this concept is that it is similar to some programming language constructs where we don't give a name to a function. So this is, you can say, an unnamed function. It exists only as part of the definition of a variable, or it only exists as an execution call to another variable. So you can say that that name of this function is basically the name of the variable. So when I execute the variable, that's when the a function in the background gets executed. So what I mean by that will be clear now. So what I want to do, let's say, I hope you can see my screen. I want users will enter a number and I want to display the square of that number. So for this, what I can do very simple, I can create a function like my square, and then I'm going to take the input, and then I'm going to say that simply you can uh, return x to the power 2. This should be small x, right? If I define this function, it works well. Then I'm going to call this function my sq, and then I'm going to pass, let's say, 10. If I execute this, it gives me the square of 10, right? Now, how do I write a lambda function using this example? Right? It's a very, very simple thing, and we are going to see what is the the advantage of doing this. Okay, the advantage of doing this is better readable code and better manageable code. So I do not need to write 2 lines, 5 lines, and 7 lines of code. I can do it in a single line. So same requirement. Sorry, same requirement again. So what do I do this time is that I create a variable which is like my sq, let's say 2, is equal to lambda. I use this keyword lambda where I assume that somebody from somewhere is going to give me a value of x. If somebody gives me a value of x, I'll simply consider that value as an integer, and what I'll do, I'll simply do an x to the power of 2. So this is by far the most simplest implementation of, let's say, lambda function. Even more simpler will be to take a number and return the same number. So what is happening over here? Let's try to understand. How lambda works basically is lambda has a keyword which is lambda, and then you have an input, and then after the colon you have some kind of operation which is nothing but the output, or you can say the return. Okay, so what is happening in this case is, oh sorry, I think this is a functionality in, okay, yeah, I got it now. Okay, so, oh shit. So what we are doing here is, yeah, so it is something like this. So we are uh, using a keyword called input, and then we are defining the lambda function using the name lambda. Then we are saying I need some input, and then I'm going to put a colon, and then I'm going to do some operation on that. Okay, this operation will be extended. I'm going to show you examples where I can have some flexibility in the conditions or in the operations, in the output, in the return. I can do majorly 4 types of operations when it comes to lambda functions, but I'm going to go through each and every one of them. But let's first see what has happened with this mysq2. So mysq2 is basically now a variable where I can actually pass a value. Okay, so if I pass a value of 10, it also gives me the same thing. Okay, if I do a type of mysq2, it is a variable of type function. Okay, this is basically a function which is almost the same as my sq. So if I just fix the typing mistake here, as you see, I've just defined a kind of a variable mysq2 and given an equal to sign. Earlier, when I was defining a function, I was using a def keyword to define the function. I was giving a name, giving the input variables if there are any, then a colon, then going into the next line, inclusive of indentation. I'm returning a value, or I'm doing some calculations, then I'm going to finally return some value, or maybe it'll simply be a void function, it's going to print something. But in this case, what I'm doing is, I have a name. I have simply a declaration of a variable which we have done earlier, like int, or like, let's say my int is equal to 1, right? So in the same way, I am declaring an entity called mysq2 is equal to lambda x colon x to the power 2, which you can see in line number 3 or execution number 3. In which case my input is x and the operation which I am actually performing is x star star 2, which is x to the power 2. So this is how, as simple as it sounds, we define a lambda function. Now we can extend this to many more kinds of functions. Example given, let's say my list is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have a list which is my list. Now I need to define, give me 1 minute. I need to define, let's say, my list fn, or I should say my list fn, or my list function, a kind of function or a variable which I'm going to run on my list, is that lambda x, for any input x, I'm going to say if x percentage 2 is equal to 0, then x. Okay, or maybe I can just say x if x percentage is 2 is equal to 0. So what I'm trying to do, I'm simply trying to create a lambda function. Let's see if this works. Where I've given a keyword, I'm expecting some input, and output should be that number if that number is divisible by 2, right? So let's see if this function definition works. The answer is no. Why it doesn't work is because, can there be complex logic within a lambda function is something that we are going to explore. We are going to look into documentations and we are going to explore if that's going to work, because this is something which we have already done. In the last class, we looked into list comprehensions. Okay, day before yesterday, we looked into comprehensions where we can do such kind of operations very easily, right? We could have done this very easily using list comprehensions, but since we are learning lambda functions, I need to know what happens if I have more than one value, because I've already seen what I can do with a single value, right? I can pass the single value, get the square. What happens when I have a set of numbers? Is there any way? So let's see. So here I'm going to share this link with you all. So here I have, let's say, the lambda function. As I said, there will be arguments and there will be expressions. So I want any number to be added with 10, I'm doing a lambda function like this. Any two numbers which are getting multiplied by this, I can do that as well. So these are examples. Any three numbers which are getting added, I can do that as well. Okay. But if you look at any example, you will never be able to see that there are any complicated things that a straightforward lambda function can do. Now this is really a problem. Okay, let's see. Lambda function, Python, if else. If you do this kind of a search, let's say, what happens? Okay, inside a lambda function, can there be such kind of branching, or can there be such kind of, let's say, if else conditions that we can have? Okay, the answer seems to be yes. So for example, I have lambda x, so I have a piece of code over here which is something like this. So I'm just going to take a copy of this and I'm going to paste it over here. Let's see what this is doing. So what this is doing is, I have a variable, or I have a name which is test, and it is saying lambda x colon true if x is greater than 10 and x is less than 20, else false. And then if I execute this, it is giving me the output. Now what happens if I pass my list into this function? It is executing and then it gives me a type error. Why? Because it is not able to perform these operations on a set of numbers. So what I'm seeing over here is, there is actually a way in which I can do this, but there is no way to use lambda functions in case of multiple values. Okay, example given. Let's try to do the same thing that we have done over here. Lambda x is going to return x if x percentage 2 is equal to 0. Is this function going to execute? The answer is no. Right? Why is this not executing? Let's see if I do this. Is this executing? No. So I'm trying to put an if condition which is similar to this, and then I'm trying to return the value itself, and it does not return me the value. What happens if I replace this with true? Even in this case also, okay, I made a mistake there. Even in this case also, it is not doing. Okay. If I add a else part and say x, is this going to compile? The answer is yes. What if I replace true with x? The answer is yes. What if I replace this else with 0? The answer is yes. What I want to do over here, as you can understand, is what are the limitations of using a lambda function. We are using a lambda function where I need to have some kind of nested if-else statements. You can see I have to use else statement. If I do not use this else statement, I'll simply remove this and I try to execute. It shows that there is a syntax error, right? I'm using a lambda function, which is an unnamed definition of a function within which I need to do if statement. I need to use an else part as well. Now this thing may well work. So let's see if I pass a value of 10. The answer is yes. Because 10 is divisible by 2, it gave me a value. What if I say 1? It is going to return me 0. Now what if I want my list? The answer is again, it is not giving me any output. Fine, that is one way of doing it. We already know we have the concept of for loop. So for each item in my list, I am simply going to do my list fn and each item, right? Let's see what this does. This does not print anything on the screen because I don't have any capability written inside the lambda function to do a print. All I have is a calculation. So this function, this for loop over here, I'm sorry, is calling the lambda function myListFn. It is doing the calculations, but it is not printing it anywhere. How do I solve that problem? I can take a temp var or a temporary variable, which is something like this. And then I can simply print temp. In this case, I now get the output. Now again, I'm using a for loop. So what is happening is there are a few restrictions when it comes to lambda functions, but lambda functions are very useful if I have straightforward, simple, let's say, definitions which I can try and execute. Okay, this is going to be very powerful when we do the data analysis, because there will be cases where, let's say, I have a data set and I have a lot of columns, and in one specific column, I want to find out the records which are divisible by 2, or I want to find out the records which starts with the character S, right? So in that case, this kind of a lambda function is going to be really, really very useful. I can use that function directly on that, let's say, data frame, on that list of items. But then the only limitation I'm going to get is that, just a moment, there is some kind of chat which is, can we do lambda x print x? Let's see. Okay. So let's see if we can do lambda x print x. My val is equal to lambda x print x. Okay. The definition is created. My val. The answer is yes. We were able to do that. What happens if I don't pass a string and I pass a number which is, let's say, a decimal? The answer is yes. So to answer your question, Rahul, the answer is yes. We can do any operation inside this. That is not a problem. The problem here is if I'm going to use conditionals, or if I'm going to use, let's say, a list of values. Let's say I want to print 10.23 and then 11, then 23. In this case, it is going to give me an error because it cannot handle more than one value at a single point in time with this kind of a definition. So that's where our limitation is. Then again, we saw a limitation over here. If I'm going to use an if-else statement, I need to do something like this. I need to have an if as well as an else. I have to handle this somehow. Else I need to go back to for loops, and I don't want to do that. The reason being, if I go to for loop, there will be a time and space complexity. We have already seen that the number of executions of each and every iteration of the for loop is going to decide how complex or how space needy the for loop is going to be. And that's the reason why we can't always do a for loop, right? Imagine you have a data set which is 1 GB of size and you need to do some kind of operation on a column. Do you really think a for loop is going to be the right option? Your data analysis pipeline is going to run for hours, if not less. And that will also going to depend on, let's say, the kind of hardware you have. So basis the infrastructure, your for loop may well work, but then it's really a very heavy, it's a very heavy ops. So how can I do that? So there are, as I said, four kind of operations in the start. I have already mentioned there are four operations we can do with lambda. One we have already seen, we can do simplistic calculations like these, right? The other is, or the other three is known as map, filter, and reduce. Somebody coming from a big data analytics background will clearly understand these terminologies, but I will assume that we don't know what is a map, we don't know what is filter, and we don't know what is a reduce. There is a small catch when it comes to reduce function. I'm going to show that to you. Okay, but let's see what map function is. What I'm going to do now is that I'm going to say my list is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I already have this list, but I'm just writing the statement once more. Now what I'm going to do, my list fn2 is equal to, I'm going to create a lambda function, but this time inside a bracket. Okay, in this bracket, I'm going to pass two things. In the first place, I'm going to pass the lambda function. In the second place, I'm going to pass a set of data on which I want to map this function. So that's the purpose of a map function. It takes two arguments. The first argument is going to be the application or the computation that I want to do. The second argument is going to be a set or a series or a gathering of values on which I want to do the computation. So in this case, I have my list. So the computation has to be done on my list. So the second input to this map function in this case is going to be my list. What is the operation that I want to do? I want to do an operation which is as simple as this. Let me go back. Where is the operation? This operation is this. Okay. I want to do this. Okay, let's say, or let's say I'll do it even simpler. I just want to do this. So I'll take that piece of code and put it over here, and I do an execute. So when I execute this, I'm expecting that my list fn2 is now a function. So I'm going to say type of my list fn2. Sorry, a bracket is missing. So now it says it is no longer a function, it is a map. How do I print it? How do I get the values? Fine, I have done some kind of mapping of each and every value to some other value. In this case, I've squared each and every value. How do I get the output? The way to get the output is that you convert that into a type or a data structure which you need. So I'm going to say my list fn2. Can that be represented as a list? The answer is yes. If I print this, I get the output of the lambda conversion or this function's execution of on top of my list, where each and every variable, okay, each and every variable is now executed, or each and every item in the data set is now executed by means of a function. So this function is applied on each and every entity or each and every item in the list, and I get a resultant output. Now you might be wondering, why did I take an example as simple as this? If I already have the capability of doing if else, why not take that example as well? Fine. But there was a limitation in if else, right? In if else, I have to mandatorily give else. Why I don't want to give else is because that is what I'm going to show you now. In the map function, I can only apply a certain feature or a functionality on top of a set of data, right? What can I do when it comes to selectively performing some operation? Example given, I want to do some operation on this list. It's a my list, and I only want to do that if each and every item matches certain criteria. Okay, and that's exactly what we are going to do in a filter operation. What we are going to do in a filter operation is that I'm going to say that there should be a condition like this. If this condition is matching, then only I'm going to print the output. Example given. In this case, I'll just take this here. I'll take this and I'm just going to rename this to 3. Now instead of map, I'm using a filter condition or a filter function. Okay, wait for 2 minutes, we'll come to know what is happening over it. In this if else function, what was I testing? Let me go back and let me see. I was testing if this is the case. Okay. So I was simply testing for this. So I'm going to do this over here. Okay. Let's see if this executes. The answer is yes, it did execute. Now I want to see what is the output. The output is this. So what I've done essentially over here, and by the way, this bracket was not really essential. I just did a copy paste. Don't get me wrong. This bracket was not essential there. I did a filter using a lambda function on my list. So there are two inputs to a filter function as well. The first input is the computation I want to do. The second input or the second variable or the parameter is the set of data on which I want to do. So the set of data is my list. The operation I want to do, only filter those records which are divisible by 2. Now, without writing a for loop, I have done this because this is more efficient in doing this. And the most important thing is I don't need to write a piece of code to define this function. This function is now inline. The moment I execute this variable or I give it some kind of list, let's say encapsulation, then this execution is applied on this item or the set of items, and then I get the output. So these are the advantages of using map and filter along with lambda functions. Now, before we go into, let's say, the questions and answers, one last thing that we would almost always like to do is let's say I want to not get only a mapping of the data or a filtering of the data. I would also like to get a reduction of the data. What I mean by that is, before I do that, let me just show you one quick thing. The input to a certain filter can also be from another list. Okay. In this case, it did not really work properly. Let me see why that is the case. My list 2 is equal to this. And then let's say I'm going to say my list 2. And then I'm going to print this. It is not probably working here because of this kind of a conversion. We may have to look into this. But I'm under this impression maybe we can change them as well. So we are going to try that at a later stage. But let's get back to the point. The point is, we have seen map in which we can apply a function to a set of values. We have seen filter where I can selectively get things out of a data set. Can I now reduce, or can I now output a single value out of a list of values? Example given. Here I have, let's say, 9 values. Okay, so I'm just going to turn this back. Here I have a set of values, which is 1 until 9. What if I have a field or a requirement to sum up all the numbers? Or maybe I'm going to say this, my list 3, sorry, is equal to this, and I'm going to say my list 3. Okay, it is not taking the value. That is where the problem is. It is not outputting the value. Somehow this is not working, but let's see how we can make that work. Maybe that's something that I need to look into. I'm going to look into this, then maybe we can get back. Yeah. So in the meanwhile, maybe I'm simply going to take a very simple example. I have my list where I have these many values. I want to sum them up. So I can do a for loop again, and I can do that. But there is one more better way of doing this by means of using lambda function, and that is known as filter. That is known as reduce. So what I do, my list fn4 is equal to reduce, or perform a reduction using two values. The first value I pass over here, or the second input parameter that I write, is my list. My list is going to be the input to the reduce function. The first part is again going to be a lambda function where I'm saying x comma y should return x plus y. Now, why am I doing this is a question. So the question is, the reason why I'm doing x comma y is equal to x plus y is because I want this reduce function to apply some kind of calculation on this list in a sequential order. Example given, I want to add the numbers. Okay, how do I add numbers? How do you usually add the numbers? You can't add them all at once. What you do, you add two numbers. You take these two, you add it with the third. You take the sum of these three, you add it with the fourth. You take the sum of these four, add it with the fifth. This is exactly what you're going to do in loop as well. In the same way, we are doing over here. We have only 10 minutes left. So, okay, we are going to finish this. So here what we are doing, we are taking two values and then we are adding them. So in the first iteration, it's going to add 1 and 2. It is going to give me an output of 3. In the next iteration, my x becomes 3, y becomes this 3. So 3 plus 3 becomes 6. Okay. In the third iteration, x becomes 6, y becomes 4, it gives me 10, and so on and so forth. So this is how it is expected to work. Now I'm going to execute this and we are going to get an error. It is saying name reduce is not defined. The reason why it is not defined is because out of the box map and filter functions were defined, but filter reduce function is not available in Python out of the box. Okay, for that we have to import a library from functools import reduce. Okay, functools is a module or a library where a reduce function is available. So I'm going to take this now and I'm going to execute this. It has executed now. Again, whenever I printed any value, I have used a function like this. I've converted it into a variable which I need. So I'm going to say this now, and it again gives me an error. Why? Because reduce function has reduced the value into a single value. So I cannot convert that into list anymore. I can only see the total value. You see, the summation of 1 until 9 is 45. If I add two more values here and then execute this, the value is going to change now. So sum of the first 11 natural numbers is equal to 66. We know that. So this is exactly doing a reduction. It is reducing your data set down to one value. This is very useful when we are doing, let's say, sum of a field. Although we do have functions to do sum of a field. But if you would like to do it in an efficient way, this is one of the efficient way in which we can do. So map is what we saw when we are applying a function to map a data set. Map each and every value of a data set with a function. In that case, I use map. If I want to filter specific records out of a data set, I'm going to say filter. If I'm going to reduce all the values into a conjugal values, into a single value from a set of values, I'm going to say reduce. Okay. These are the definitions of the functions. I'm going to share you the links. Maybe you should go through them. Go through the Python documentation as well. Try out a few examples. You'll come to know what this is doing. You may not entirely come to know in which use cases we are going to do that, but yes, when we do the data analysis part, may not be directly applicable onto machine learning, but when we do data analysis, we are going to make use of a lot of these tools, a lot of these techniques. Okay. I see I have only 7 minutes left, so maybe I'll go on mute. If anyone has any questions, we can utilize this time. Any questions, friend? Any questions from the previous classes that we have done? I hope you all can hear me, right?
Yes, Thomas.
Yeah. Okay. Okay. No, I don't see any questions. Can I assume in that case that we don't have any questions? I'll share these links with you. You can go through them, and we will go through the specific use cases where these things are used when we actually do data analysis. Because if I give you random, or if I'm going to show you random examples like these, you can understand how the functions are working, but you won't be able to get the context. So you can just have some patience now. We all can have some patience. We are going to look into the use cases when we do the actual data analysis part, is where we are going to use this kind of functions, right? Okay, I think if we don't have any other questions, maybe we can close the meeting. Thanks all for joining. I'll stop the sharing, and then I'll be sharing with you the links and the notebook, and of course the video. Yeah. Thank you.
Thanks, Anna.
Thank you. Thanks, Mohammed.
Thank you, Rahul. Thank you, Roy. Thank you.